My name is John Marlin, and I am a program manager on the High Availability and Storage team. I own the Failover clustering component, and this video series details many of the new features with Windows Server 2019 Failover clustering. In part 6, we talked about a few things. The cluster network name can now be a distinguished name. No more cluster IP address. Makes it good for when it's in Azure. IP address isn't always available to you. We talked about some of the enhancements for Azure, one being the distinguished name, so no more internal load balancer needed for it. Host maintenance scheduled events, the ability to react automatically to those events, and domain migrations, moving clusters between domains while keeping the cluster intact. In this last part, we're going to talk about a couple of the announcements we made at Ignite 2018 that were huge from a Storage Spaces Direct perspective. So at Ignite 2016, we showed a demo of a single 16-node Storage Spaces Direct cluster. In that demo, we showed IOPs of almost 6.7 million, which was our record and previously unheard of at the time. So for 2019, we set out to see if we could beat it. So we got together with Intel on how we could do that. Intel has their new Optane persistent memory. Persistent memory we talked about in a previous part, where it's in essence storage on a memory chip. Not as fast as memory, but a lot more faster than storage. Together, we built this system here, which is available for 2019. And it's a 12-node Storage Spaces Direct cluster. So it's actually 4 nodes less. But it has the Intel Xeon processor. It's got Optane persistent memory for the cache. It has NVMe drives for capacity. And of course, Mellanox network cards. So, just to kind of give you an idea of what it looks like, we look at it here in Windows Admin Center. You can see it's a total of 12 nodes. Everything's up, everything's healthy. 72 drives total. We have currently 312 virtual machines running. Right now they're all off. And 14 volumes that we've defined for these VMs to reside on. You can see here the storage uses of all the VMs is 91 terabytes. If I look at the servers, you can see these are all Intel machines. If I look at the inventory, you can see I've got 24 persistent memory chips to act as cache devices throughout the nodes, as well as, and then if I look at it, I can see the interleave is set on the 6, which is 6 chips per machine. I've got NVMe drives running, all of them at 7.28 terabytes. And as we talked about in a previous part, I'm going to look at this through cluster performance. And currently right now we're running at about 3,000 IOPS with very little latency. However, keep in mind all the virtual machines are off. So we wanted to see what kind of new record we could create if we could create. So let's go ahead and run it and see what our new record is, because we did beat it. And before I forget, let's add a digit to it. So here I have, in essence, what our storage spaces direct cluster looks like with all our virtual machines. Everything is off. So let's go ahead and turn on all the virtual machines of one of the server to see what it looks like. We come back here to cluster performance history. All the VMs are started up. Everything is running. We're running disk speed in the background. And you can see we're at 1 million IOPS already with just one server with running those virtual machines. I come back, I turn on all the VMs of a second server. Check Windows performance history. Let it run, let things start running, VMs are up. The speed running, we're at 2 million IOPS. And we still have a lot more to go. So, instead of just turning one after another, let's go ahead and turn them all on and see what we have. So turn all the VMs on. Come back here to Windows Admin Center. Things start running. 4 million, 5 million, just keeps increasing. 6, 7, 8, still going. Big milestone, 10 million, 11 million, and finally 13 million. 13 million IOPS. To be more specific, almost 13.8 million IOPS. Huge, huge speed, huge IOPS numbers. And remember, we more than doubled, actually about doubled our IOPS with 4 less servers. All that with the assistance and help of persistent memory. From a storage capacity standpoint, one of the things we looked at, one of the things we talked about with various different customers, what is it that you want for storage capacities? Currently, we're at 1 petabyte as a maximum through 2016. So everybody came back, and there was, in essence, 3 different things that everybody talked about, which was the first being they want more, the second being they want more, and the third being, as you guessed it, they want more. So we gave them more. 4 petabytes. Now, to put that in perspective, that's all of Wikipedia, every language, with the complete edit history, uncompressed, 50 times. So, what did we do? We got with several of our partners, Quanta, Cloud Technology, Seagate, Veeam, Accutech, Samsung, and put together a system. So, I want to show you what that system looks like now. Here I look at it in Windows Admin Center. I have 8 servers. You can see they're here, they're all up. They're all Quanta manufactured servers. If I look at the drives, there's 576 drives throughout this 8-node storage spaces direct cluster. If I look at it on a per server basis, each server has 72 drives. 8 of the drives for caching, the remaining drives for capacity, and this is an SSD with HDD drives. Because remember, this cluster is all about capacity, not necessarily speed. Each of the drives being 7.28 terabytes. And as you can see here, over 3.64 petabytes of raw storage. So we're not just saying, hey, here's a theoretical limit. It's like, here's the limit, and here's what we can do. 3.64 petabytes is the largest storage spaces direct cluster by capacity that we've ever done. If you look at it, this is what the solution is, and it's a backup solution. Again, this is sheer capacity driven. This is a system that is available now and can be run. Available for purchase through the Azure Stack HCI program through Windows Server Software Defined. It's already there. And some of the stuff that we found about it, it can do 25 gigabytes of sustained data, meaning writes, which is nearly 100 terabyte per hour of what it is writing. Huge system for what it does. It's pretty fast. So to wrap it up, over 13 million, almost 13.8 million IOPs, very fast, super fast machines using Intel's persistent memory. We talked about the capacity limits of 4 petabytes. We didn't just say it, we proved it. And to wrap this whole series up, which I don't want to go through everything, just hit a few of the highlights. We kind of looked at the past, what it was like with 2016, some of the recognitions we've got for it, CRN Product of the Year. Looked at the future, what is it we're going to look at? How do we make things better with 2019? System insights, cluster performance history. Looked at, talked about PMEM, persistent memory storage. Actually identified a new IOPS record. Some of the new witness updates for no longer allowing for DNS or DFSR that could possibly cause split brains. Some of the split brain detection that we've done. Adding file share witness for USB. Some of the integration we did with Azure, detecting it's within Azure. Distinguished cluster network name, Azure host maintenance schedule events, being able to react to those events. Cluster sets, our scale out technology, in essence clustering clusters together, and so much more. In the blog, I've identified and give you all the links for the majority of all this stuff. So I do want to thank you for watching this series. There is my Twitter account. I do blog about, tweet about clusters. If you have any questions about clusters, please feel free to tweet me about it. I also make announcements through my Twitter account for any new features. Obviously, nothing's coming out anytime soon, but towards the end of 2019, we will start making some newer announcements on some of the new stuff. I look forward to talking with each of you, or some of you, whoever gets in touch with me. I also want to sincerely thank you for watching this video series. Thank you.